Electrical systems are vulnerable to voltage spikes from lightning or switching surges. Surge arresters take over in these high voltage situations. They reroute power surges to Earth to avert damage to the grid that would cause power failures and power cuts. When lightning strikes, surge arresters handle the fallout. They divert the ensuing power surges to Earth, where they won't cause damage. At their core are discs that act as switches. They turn on and off to divert voltage spikes. The discs are known as MOVs, which is short for metal oxide varistors. Fiberglass strapping is looped onto aluminium end caps to prepare the casings for the MOVs. A spacer is placed on top of one of the end caps. Then, numerous MOVs are placed on top, equipping this arrestor to divert a kilovolt power surge. More spacers are added to fill in any gaps. The MOV stack must sit tight within the casing. With the stack complete, more fiberglass strapping is placed around the MOVs to complete the casing. A set screw is used to compress the stack. The set screw also pushes back the end caps, which pulls the fiberglass strapping tighter. The surge arrestor assembly is then clamped between two mandrels. A resin-reinforced thread is wound around the fiberglass loop at one end. The mandrels then spin the surge arrestor module as a computer-programmed dispenser winds the thread around it to strengthen it. It creates gaps between the windings. This will allow sparks and fumes to escape in the event of a power overload. With the winding complete, the end is cut and tucked under the last winding. The module is then hung on a rack conveyor, which takes it into a chamber. Here, a tank filled with an adhesive-promoting solution rises up and immerses the module. This leaves a coating that will help a silicon rubber housing bond to the module later. The hooks used to hang the module on the rack conveyor are removed, and mandrels are placed at both ends to be used at a later stage of processing. The module is placed between the rungs of a chain-driven conveyor. It takes it through an oven set at 150 degrees Celsius. This cures the resin in the thread, causing it to harden around the fiberglass strapping. It also preheats the surge arrestor module in preparation for the next process, the molding of the outer housing. Using the mandrels, two of the surge arrestor modules are locked in a platform and slid under a mold press. A lift takes it to the press. The press injects silicon rubber into the mold and, using pressure and heat, forms an insulating jacket around the arrestor modules. The primer coating enhances the adhesion of the silicon rubber to the modules. Any unwanted bits of silicon rubber are clipped off the molded housing, and the ends are cleaned up with a wire brush. Surge arrestors come in a range of voltage ratings for different electrical systems. The threaded bolt holes in one end are then lubricated, and the holes are aligned with the ones on a terminal connector. The connector is bolted to the surge arrestor. A base is inserted on the other end. This base will allow the arrestor to be mounted on the ground and send excess voltage into the earth. Finally, it's time to test the surge arrestor. The engineer connects the electrodes to the terminal connector and to the base. He runs different voltages of electricity through the arrestor and confirms that it discharges them. It's now ready to join the others on the grid, forming a defense against lightning strikes, power spikes,